Hi everyone, this video is on the mixed exercise 12, question 12. So we have a curve C with the equation y is equal to x cubed minus 5x squared plus 5x plus 2, and in part A we want to find dy by dx. So we first differentiate this function and we get 3x squared minus 10x plus 5. And so in part B we have 2 points P and Q, which are on C, so they're on the curve. The gradient of C at point P and Q is 2, and the x coordinate of P is 3. So we want to find the x coordinate of Q. So whenever you have the gradient and you want to find a specific x coordinate, the x coordinate of a specific point, all you need to do is that you just set the derivative equation equal to the gradient, and then you find the x, right? Because when you want to find the gradient, you substitute the x coordinate of the point that you want to find the gradient of into the divide by dx equation. But this is like the opposite case where we have the gradient, but we want to find the x coordinate. So we just solve the equation divide by dx is equal to the gradient. So the gradient is 2. So divide by dx is equal to 2. So if we solve this equation, we are going to get the x coordinates of the point Q. Now you might be asking, what about point P? Because point P also has still has the same gradient as Q. And let's solve the equation and you will see we will see the answer to that. So we first solve 3x squared minus 10x plus 5 is equal to 2. And we are going to have the quadratic equation 3x squared minus 10x plus 3 is equal to 0. So if we solve this quadratic, we can factorize or just use the quadratic formula. The solutions of the quadratic are going to be a third or 3. So maybe, yeah, let me just, we can write down the factorization, because that factors to 3x minus 1 times x minus 3 is equal to 0. So we get these two solutions. And so now that we have the two solutions, so one is that's a third and the other one is 3. So the interesting thing is that we got two x coordinates, but only one of them is for Q. And remember that earlier we discussed about point P, because point P has the same gradient, so that's why we have 2 points that they get the same gradient. So that's why we got two x coordinates. And they have told us that the x coordinates of P is 3, which we also got that. So this is the x coordinates of P, and this is the x coordinates of Q. So that's a third, and that's the answer to part B. And yeah, actually it was part BI. So BI. Okay, now for the second part of the question, we want to find an equation for the tangent to C at the point B and giving your answer in this form. So we just need to substitute the coordinates of point P and the gradient into the equation of the line to get that. So we first need to find the y coordinate of the point P. So point P has x coordinate 3, and so when x is equal to 3, so y is minus 1, and so that's the y coordinate, which means point B has x coordinate 3 and then y coordinate minus 1. And then remember that the gradient at point P is just equal to 2. Yeah. So now we can use this equation y minus y0 is equal to m times x minus x0. So it becomes y plus 1 is equal to 2 times x minus 3, and now it's all about rearranging. So we have 2x minus 6, and we'll get 2x minus 7. So this is the equation of the tangent. Equation of the tangent at point P. Yeah. Okay, and finally for the last part, if this tangent intersects the coordinate axis at the points R and S, find the length of RS, giving your answer as a set. Okay, so this part is interesting. It's basically saying that the tangent line is going to intersect the both of the axes. So that means it's going to be something like this. So it intersects both the y-axis and x-axis at two different points, because it says that, yeah, the coordinate axis. So yeah, that means both of the axes, and that's why we have two different points. Because if it was only one axis, then we would only have 1 point of intersection, but now we have 2 points of intersections. So we want to find the length of RS. So remember that in order to be able to find the length of a line, we need to have the coordinates of basically both ends of the line, so we can use the formula of the distance. So that means we need to, if we call this line, sorry, this point R, and then this one S, we need to find the coordinates first. And it's actually simpler than you think, because we know the equation of the tangent, right? We just found that that's equal to 2x minus 7. So now the 2 points are basically the x-intercept and y-intercept of this line. So we just need to find the x-intercept and y-intercept, and then we can find the distance. So for the last part, the equation of the tangent is equal to 2x minus 7. So we first find let's find the x-intercept. So in order to find the x-intercept, we set y, we set y equal to 0. So we have then 2x minus 7, and x is equal to 7 over 2. So that means one of the coordinates, this point here, this is the x-intercept. That point that we called S has coordinates 7 over 2 and 0, right? Because that's the x-intercept, so its y-coordinate is 0. That's why we set y equal to 0. And we repeat the same trick for the y-intercept. So this time we set x is equal to 0 because y-intercept has an x coordinate of 0. So that means we are going to have y is equal to 0 minus 7, and y is just equal to minus 7. So the other point that we called R has coordinates 0 minus 1. Now that we have the 2 points, we can then find the distance of RS, and the formula of the distance is basically x2 minus x1 squared plus y2 minus y1 squared. So in this case, we just need to substitute the coordinates basically. So for the first part, which is the difference of x, we are going to have 7 over 2 minus 0 squared, so that's 7 over 2 squared. And then for the second part, we are going to have 0 minus 7 squared. Sorry, here is minus 7, so it's going to be 0 minus minus 7. So like this, 0 minus minus 7 squared, and we'll get 49 over 4 plus 49, and that's equal to, if you simplify this, it's going to be 7 root 5 over 2. So that's basically the distance between the two points R and S. Okay, that's it for this video, and thank you for watching.